Recently, scientists have collected new data, giving them a better picture of Yellowstone's underground plumbing. Right beneath the caldera, from the last eruption, sits the magma chamber. And it's fed by a plume of magma stretching down 465 miles northwest into Montana. It's mostly solid rock, with the potential to liquefy. And scientists are closely monitoring it. Magma, or molten rock, is rising through the plume into the magma chamber at 2 inches a year.
There's no reason for it to stop, although it might come in spurts. Our images show wider parts and narrower parts, so it's like slugs of material that are flowing in a sewer line. And this restless Yellowstone caldera is truly living, breathing. Every once in a while, it burps.
The danger is if the plume starts liquefying and moving up at a faster rate.
Natural systems can throw us a lot of curveballs. A lot of things can happen that we're not really ready for.
Scientist Jake Lowenstern is looking for a pattern connecting the supervolcano today and its 3 prior major eruptions. 2.1 million years ago, 1.3 million years ago, and 640,000 years ago.
In 2 of the really large eruptions at Yellowstone, so much material comes out, entire mountain ranges end up falling into the ground and essentially disappearing.
One 50-mile stretch of mountains simply disappeared by collapsing into the magma chamber. University of Toronto geologist John Westgate has tracked the ash from Yellowstone's prior eruptions.
It covered much of the United States. It occurs right out in the Pacific Ocean. It even found in the Gulf of Mexico. Up in northeast Montana, there's a site that we're working on. The tephra is over 7 meters thick. These eruptions are enormous. The amount of material erupted from them, huge.
When Mount St. Helens erupted in May 1980, it blew off one side of the mountain and triggered an avalanche of snow, mud, ash, and rock. Driven by the wind, the ash landed in 11 states and up into Canada. But that's nothing compared to the amount of ash from Yellowstone's last 3 major eruptions. In magnitude and volume, each one was far greater than Mount St. Helens. Today, there's little evidence of the supervolcano's violent past. The 50 by 30 mile caldera from the last eruption was covered by lava and ash and smoothed over by glaciers. Forests now conceal the scars.